Okay, first of all, this question is question 4 of the lesson 204. Um, so let's take a look at it. So an electronic game randomly selects 5 coins. They are a 10 cent, a 20 cent, 50 cent, $1 coin, and a $2 coin. If a selection is made without replacement, complete the probability table for the total value of the coins. Now, the key thing with this question is trying to work out the probabilities is I need to know how many there are in total, or how many different combinations there are, and which one of those are less than $1, between $1 and $2, and greater than $2. So the key thing is to create your sample space here, where you have the values. So I've got my 10 cent, 20 cent, 50 cent, $1, $2. Sorry, a bit old fashioned with notes, so even though it says coins. 10 cents, 20 cents, 50 cents, $1, $2. So this one represents the first coin, and this one represents the second. So what we can go through like a multiplication table is work out what each one is. So this is 50 cents and so on. And I've got a completed table here. So remember, this is the first coin. This is the second coin we draw. So the other key thing we need to work out is how many of those are less than $1. But actually, the most important thing is looking at the question where it says without replacement. So what does that mean? Without replacement means that if you take it out first time, you're not going to then get it again because there's only one of them. So in our sample space, we end up getting rid of those. So if we go back now, so there's no way, without replacement, there is no way of getting two 10-cent coins. You either pick it first time or you pick it second time. You don't pick it at all. So if we look at the first column, so everything less than $1. So that means for the probability, what is the total? It means all of them are going to be out of 20. Okay, and this one must be out of 20 because there are 20 possibilities without replacement. If we look at that, how many of those are less than $1? We've got 1, 2, 3, 4, 5, 6. So 6 out of 20. I'll quickly change colour. So the next one is looking between $1 and $2. So we've got 1, 2, 3, 4, 5, 6. So there's another 6. And the last one, obviously more than $2. 1, 2, 3, 4, 5, 6, 7, 8. So 8 out of 20. So moving on to our second example, we ended up with 6 over 20. We ended up with 6 over 20. And we ended up with 8 over 20. Looking at our second example, this time it's with replacement. So no longer are we crossing out those double ups, we're keeping them in. And also our answers are out of 25. So we write them there. So we can count up our less than $1. 1, 2, 3, 4, 5, 6, 7, 8. 8 out of 25. Have to be really bit careful about the next one because the next one is greater than $1. But because of that sign there with the line underneath, it means we include anything that is $1. This one doesn't have a line underneath, so it must be less than that, so it can't include $1. Where's my colour? So we've got 1, 2, 3, 4, 5, 6, 7. And again, there's 7, and there's no line under there, so I'm not going to include $2. And that leaves us with the last lot: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 out of 25. So there's the probability. So the next part is Harry is playing a game and wants to get at least $1. What game should he play? So we want the probabilities to be able to work out what the probabilities are, where we end up with a result that's $1 more. So we're going to take this one and that one and add them to that one and that one, because they're the results that end up with you having more than $1. The only problem is we aren't going to know what they are. No, we are going to know what they are. So what we can do is add them together. So the first one, so without replacement, it's 6 over 20 plus 8 over 20, which gives us 14 out of 20. Likewise, with replacement, it's equal to 7 over 25 plus 7 over 25. 10 over 25, which gives us 17 over 25. So which one has the better chance of getting it more than $1? Truth is, we don't know, because it's really hard to compare fractions. So that should be 25. It's really hard to compare fractions, so what's best is to convert those into decimals, and I'll do that now. After working that out, you can see that the probability of getting more than one or more, is 0.7, and without replacement, it's 0.68. So you are more likely to get it without replacement. So we should play the game from A rather than B. The next part of the question is just putting the graphs together. So convert the probabilities all to decimals, and then you can plot them on the graph as you normally would any other graph.